Hi, in this video, I'm going to talk about EIGRP for IPv6. If you'd like more information on EIGRP for IPv6 or IPv6 in general, I'd like to suggest my book, IPv6 Fundamentals, the second edition. Also my video series, Live Lessons, IPv6 Fundamentals Live Lessons, both available from Cisco Press, just if you're interested. Okay. So there are routing protocols for IPv6, including EIGRP for IPv6. And we're going to be looking at classic EIGRP for IPv6. There's another configuration method known as named EIGRP that uses address families. And I talk about those both in the book and the video, and that's kind of how routing protocols are the trend to configuring routing protocols. But the result is the same. So let's get started here. The basic operations and algorithms you learned about, EIGRP for IPv4 is the same for EIGRP for IPv6. Okay, some of the comparisons between them. They both advertise their appropriate networks or prefixes, whatever term you prefer. Both distance vector routing protocols, both use dual, both use the same metric. Default is bandwidth and delay. The transport protocol is reliable transport protocol. Partial bounded updates. Neighbor discovery is hello packets. The only difference is EIGRP for IPv6 uses the link local address as the source address. Okay, you can see that there, the destination address. The multicast for IPv6 is FF02. That's the multicast with link local scope, :A, which is 10 in hex. Authentication. The router ID is a 32-bit router, 32-bit router ID, both IPv4 and IPv6. So that's important because as we'll talk about here in a moment, if you don't have any IPv4 addresses on the router, you must use the router ID command to specify the router ID, which you should anyway. All right, comparing EIGRP, IPv4 and IPv6. In IPv4, there's EIGRP, IPv4 neighbor table, topology table, and an IPv4 routing table. For EIGRP for IPv6, the neighbor table and topology tables are separate, along with, of course, the separate IPv6 routing table. Okay, we talked about EIGRP messages are sourced from the link local address of the router. That's why you see link local addresses in IPv6 routing protocols. And the destination address is either the multicast address or could be the link local address if it's a unicast of the destination router. Okay, here's our topology. Let's just remind ourselves how to configure IPv6 addresses on a router, including the link local address, which can be the same on all interfaces. Remember, link local addresses only have to be unique on the link. Okay. All right, so I've got some serial links here, which is kind of uncommon, but that's okay nowadays. Notice that both interfaces have the same link local address, and that's okay as long as that's unique on the link. Let's get into the configuration. First of all, we need IPv6 unicast routing command. This does several things. First of all, it allows you to configure an IPv6 dynamic routing protocol. It also allows the router to forward transit packets for IPv6. There's one other thing very important, and that is it will now start sending out ICMPv6 router advertisement messages out its local area network interfaces. Okay, so now because we did that command, we can do IPv6 router EIGRP2. And the same as in EIGRP for IPv4, the AS process ID number must match on all routers. There's our EIGRP router ID command. Okay, best practice, use it. You will be required to use it if there's no IPv4 addresses on the router, because it requires a 32-bit router ID. Okay, uses the same process. So if you don't do this command, it will see if there's a loopback IPv4 address on the router. Choose the highest one. If there are none, it will use the highest active IPv4 address. If there are none, then it's going to complain saying you need the router ID, which you should do anyway, right? Okay. No shutdown command is required on some older iOSs. Okay. To configure EIGRP for IPv6 on the interface, it's quite easy. Just IPv6 EIGRP and the process ID. Make sure that's the correct process ID. You'll do that on all interfaces. So there we've done it for router R1. Similarly, we'd do that on R2. Okay. In doing so, I do show IPv6. Let me go back there just so we can take a look at that real quick. Pause for a second. Okay. All right, simple enough, I hope. Okay, in R1, let's do show IPv6 EIGRP neighbors, and there we see our neighbor R2. We see the linked local address of our neighbor R2. This R2 sends its hellos sourced from its linked local address, FE80:2. It also includes the exit interface because FE80:2 could be a neighbor on another interface. Remember, those only have to be unique on a link. Okay, show IPv6 EIGRP topology. Dual is the same for both IPv4 and IPv6. The only difference in this command is that we see the link local address of the routers. Okay. Again, that's because all the messages, EIGRP messages, are sourced from the link local address. Okay. Feasible and distance and reported distance, that's all still the same. All right, so hopefully that gives you a little introduction to EIGRP for IPv6. And we'll talk more about it in later videos.